So let's start our discussion of completable futures by taking a bigger picture view of reactive programming. So what is reactive programming? So reactive programming is an asynchronous programming paradigm, we'll talk more about what that means in a second, that's concerned with processing streams of data and propagating changes, emitting results under the right circumstances. And you can read about it here with a Wikipedia article, which will say more or less what I'm going to tell you right now. It's particularly useful in certain scenarios, under certain conditions. So one thing it's very useful for is processing user events in user interfaces like Android or iOS. In those environments, you've got a stream of events, things like mouse movements or touch events, signals from different sensors like GPS devices. And so those sensors come in and they're emitted by a publisher, and then they're observed by something. And so you'll end up having these observables and observers, which they're called publishers and subscribers in a different context, being able to emit events and then do something with them as they receive them. So that's one place that they work out very nicely. Another place they work out very nicely is responding to and processing latency-bound I/O events, where there could be a delay if you're not able to respond. It'd be responsive and respond with a low degree of delay. So a good example would be handling asynchronous network I/O in a publish-subscribe environment. So imagine you've got a Twitter feed, or I guess it's an X feed now, and you're going to be getting a stream of events that come in, and you want to do things to them. You might want to flow control them. You might want to filter them. You might want to conduct sentiment analysis on them. You might want to group them by different observers who care about them, and then indicate whether people are happy, unhappy, indifferent, and so on and so forth. So a stream is coming in, and you want to process that stream as it flows through the reactive programming abstraction, which is typically called a reactive stream. Another way that this is handy, and if you take my class next semester, you will learn about this, is communicating between microservices or from a front-end consolidator service, like some kind of API gateway, to back-end microservices in a modern web-based computing environment. So clients send requests, they go to the API gateway, and then the API gateway disseminates them back to the microservices, and everything runs asynchronously. It's really actually very cool. And in fact, if you have an asynchronous enabled client, you can have asynchrony from top to bottom, which under some circumstances is a win. We'll talk next semester more about this, about when this approach is appropriate versus other, even more modern approaches like using structured concurrency and virtual threads. And there's some fascinating trade-offs between those different approaches. But for now, we're going to focus on reactive programming. And there are four key principles: responsive, resilient, elastic, and message-driven. And they're not all quite the same thing, but I mean, they're not all quite at the same level, but let me walk through them very quickly. So responsive means you want them to provide a rapid and consistent response time, meaning that you don't want to have large gaps or large delays between processing of events. So you'd like to have some kind of upper bound on how long it'll take to handle something, and you don't want to have some kind of hourglass or spinning wheel or the dreaded spinning icon that Mac or Windows used to do because the threads were unable to keep up with what was happening in the background. You also want systems to be resilient. What does that mean in this context? It means you want the overall system to continue to work even if some pieces fail. So if there's so-called partial failure, you don't want partial failure to bring the entire system down. Another key theme. Another theme that's very important is elasticity, which just means that even as the workload goes up, you want performance to be able to continue at a reasonable pace and auto-scale the processing that's devoted to the underlying processing platform. So auto-scaling is very important. So you should have responsive behavior, which is responsiveness, even if the workload gets higher. And then the fourth principle, which is a little different from the other one, is message-driven. So the other ones are really like quality attributes: responsive, resilient, elastic. Message-driven is really more of an implementation detail. That talks about the means by which this platform is implemented and the other principles are achieved. So message-driven means asynchronous message passing, which gives you loose coupling, isolation, location transparency, and so on and so forth. So this one is less important in some sense, but it's the way that things typically work under the hood. So that's just a very quick overview of reactive programming from a principal point of view. Now, at this point, I would not expect you to be able to do anything useful with this if you don't already know what this is, and we will, of course, talk in more detail about how this actually applies in just a second.